So we would like to compute the Laplace transform of this piecewise defined function. So what we have to do is that we have to calculate this improper integral in order to compute that transform. And here I have made a typo. It's negative st. All right. So when we calculate this integral, what we can notice is this, that here we have the function defined differently, as I said, piecewise. So here we will go up to pi over 2. All right, and what is ft there? Ft simply is 0 in this region, right? Okay. And then for the remaining, that is starting from pi over 2 to forever. All right. So what we got here is ft is how much? Cosine of t, right? Okay, so that's cosine of t. And of course, this part is going to become 0. So what we will have to work on is simply this portion, all right? And which we can do this, which we can calculate by working on it by integral by parts, all right? You know, remember that UDV method. Or we can do this, we can just, in this case, since we know how to do that already, we can just use it from table of integrals, that is. So just use this rule, okay? And so let's just go ahead and do it that way. So when we apply that rule, we get this integral equal to this quantity. And now we are just going to go ahead and take the limits. So the way we do that is this, that is, we are going to first, let's do this, or we know that the lower limit is pi over 2. So let's calculate that one first. So what do we have here is that t is going to be pi over 2. We'll just write that here, okay? And this becomes how much? Pi over 2, right? So we got pi over 2 here, and then we have what? Then we got pi over 2 here. So you can see that sine of pi over 2 is 1 and cosine of pi over 2 is 0. So this will simply become how much? E to the negative s pi over 2 over s square plus 1. Now for the upper limit, what we have to do is we have to take limit as t goes to where? As t goes to infinity. Let's take up these quantities separately. That will be easier. Okay. So what you have is e to the negative st, okay, over s square plus 1, and then times sine t. And since you saw, since s is positive, remember, our s is a positive quantity, and sine of t is bounded. So you can see, you can use, if you want, you can use, you don't have to use L'Hopital, just go ahead and, since s is positive, this will come to the denominator. So as t goes to infinity, this part will be 0, and this is bounded. So by squeeze theorem, this limit will be 0, okay? And then when we go to the other part, okay, just a moment, when we go to the other part, that is e to the, this one, that of s cosine t, okay? So let's put that s here, and we'll put cosine t on this part here, sorry. So here again, s is positive, so this will go to the denominator. So as we let t go to infinity, this factor will go to 0, and this is bounded, so this will also be how much? This will also be 0. So for this value, what we notice is this then, that is, let's paste it here. So you saw that the upper limit is 0 because these are these zeros, and then minus just a moment, the lower limit is how much? The lower limit is this, that is the value at pi over 2. So the answer will simply be how much? Simply negative e to the negative s pi over 2 over s square plus 1. So let me know if you have any questions on this.